Imagine this. Sat outside one morning expecting the soft golden light of dawn. But instead, the sky is blazing white. Two shadows stretch from your feet.
The air feels hotter. Too hot, but it's only out.
Birds are screaming in confusion. And above the horizon, not one, but two suns rise together, flooding Earth with a light so intense it feels like reality is bending. For the first time in human history, our world is no longer a single star planet. Earth has somehow been pulled into a binary star system, two suns orbiting one another like Tatooine, the iconic twin sun world from Star Wars. At first, the sight is beautiful. Two colossal fireballs hanging in the sky, painting everything in impossible colors. But within minutes, the beauty turns terrifying. Temperatures begin to soar. Oceans reflect twice the energy. Plants start reacting violently to the sudden overload of sunlight. And scientists all over the world send out an emergency broadcast. Do not go outside. Benim drink med up. The skinny throat tends to immerse free students give you the good.
Ik zei het jou. For mindset, I was my goodness, believe fascination is like with a light.
Because this isn't just twice the brightness, it's twice the gravity influence. Loaded legs and how solar and twice the radiation, twice the chaos. If Earth had two suns, everything you know about day, night, climate, seasons, and survival would collapse instantly. And the planet would begin a radical transformation, one we are not prepared for. What happens to our world when every sunrise becomes a double sunrise? What happens when Earth becomes a twin star planet overnight? Before we unravel the science, the danger, and the breathtaking consequences, please like this video, subscribe to the channel, and comment your question below. To truly understand what would happen if Earth suddenly had two suns, we need to establish the rules of this hypothetical. Not all twin star systems are the same. Some stars orbit each other closely, others are widely separated, and planets behave very differently depending on their position in that cosmic dance. For this scenario, we'll imagine the most dramatic and scientifically intriguing version. Earth now orbits a pair of suns, a binary system, where our original sun has a partner star of similar size and brightness. These two suns orbit each other tightly, creating powerful gravitational effects while illuminating Earth with nearly double the light and heat. Why is this scenario so captivating? Because binary star systems are common in the universe. In fact, more than half of all sun-like stars are part of multi-star systems. That means planets with twin sunrises and twin sunsets aren't just sci-fi, they're a real, astronomical possibility. But Earth was never built for this. Our climate, atmosphere, oceans, and even our biology evolved under the influence of a single star. Introducing a second sun instantly throws every natural system out of balance. Days become unpredictable, seasons warp, tidal forces intensify, radiation levels spike, and planet-wide ecosystems begin to transform in ways we can map using real astrophysics and climate science. In the next parts, we'll break down step by step how Earth reacts to the shock of becoming a two-sun world, from the atmosphere to the oceans to life itself. First, major consequence: a broken day-night cycle. The first and most immediate transformation hits the moment the second sun rises. Earth's day-night cycle collapses. Our planet evolved around a predictable 24-hour rhythm. Every biological system, human sleep cycles, plant photosynthesis, animal migration patterns, depends on the steady pulse of light and darkness. But with two suns, that rhythm is shattered. Depending on the orbital geometry, Earth would now receive light from at least one sun nearly all the time. True darkness becomes rare or even non-existent. Imagine midnight looking like late afternoon. Imagine starlight drowned out completely. For many regions on Earth, nights would shrink to minutes or disappear entirely for weeks. This has immediate consequences. Plants enter photosynthetic overdrive, absorbing far more light than they can safely convert. Many species begin producing stress chemicals, overheating from excess energy. Forests in equatorial regions might experience mass leaf burn, similar to what happens during extreme heat waves today, but magnified many times. Animals become disoriented. Nocturnal species lose their ability to hunt or rest. Predators dependent on darkness owls, big cats, bats face ecological collapse within days. Marine life that uses moonlight or darkness for migration becomes confused and vulnerable. Humans wouldn't be spared either. Our circadian rhythms, regulated by light and darkness, would be thrown into chaos. Sleep disorders spike, hormonal disruptions spread. Hospitals report millions experiencing insomnia, extreme fatigue, and psychological stress within just the first week. But the destruction isn't limited to biology. The temperature pattern of the planet changes immediately. With two suns, the surface heats at a rate Earth has never experienced. Temperatures rise dozens of degrees in hours. Cities experience deadly heat by midday. Air conditioning systems fail. Power grids become overloaded. Governments declare global sunlight shelter protocols.
And then there's the radiation.
Two suns mean double the UV exposure, increasing the risk of sunburn, blindness, and skin cancer dramatically. Protective clothing becomes essential. Outdoor life becomes hazardous. Nations begin deploying emergency UV shielding systems and reflective canopies over public spaces. All of this happens in just the first days. But the deeper, more catastrophic effects begin when the planet's climate starts spinning out of control. Second major consequence: the climate spiral and atmospheric breakdown. Once the day-night cycle collapses, Earth's atmosphere enters a violent and irreversible chain reaction. The presence of two suns doesn't just heat the planet, it fundamentally rewires the mechanics of global weather. The first major shift occurs in the jet streams. Normally, these fast-moving rivers of air circle the planet, stabilizing storms and distributing heat. But with nearly twice the solar energy pouring into the atmosphere, the temperature difference between the equator and the poles widens dramatically. Jet streams become chaotic, wobbling, and breaking apart. Weather systems start behaving like runaway storms on Jupiter, massive, unpredictable, and long-lasting. Then comes the evaporation crisis. With double sunlight, the oceans begin releasing water vapor at an unprecedented rate. Humidity skyrockets. Clouds become thicker, higher, and more energy charged. Storms form daily along coastlines, feeding off the superheated ocean surface. The Richter scale, which has technically been replaced by the moment magnitude scale, measures the strength of an earthquake. Since we usually hear about earthquakes with ratings somewhere between 3 and 9, a lot of people probably think of 10 as the top of the scale and 0 as the bottom. In fact, there is no top or bottom to the scale. But even if 10 isn't the top of the scale, it might as well be. A magnitude 9 earthquake already measurably alters the rotation of the Earth. The two magnitude 9 plus earthquakes this century both altered the length of the day by a time only recurred. A single hyperhurricane could span hundreds of miles, lingering over regions for weeks because the broken jet streams no longer steer them away. Coastal cities flood. Farmland is erased. Entire regions become uninhabitable. And as the oceans continue to warm, another threat emerges.
Methane release from seafloor sediments.
Methane is a greenhouse gas 80 times more potent than CO2. Once released in large quantities, it creates a runaway greenhouse effect, a self-amplifying loop of heat.
Meanwhile, the atmosphere itself starts expanding due to extreme heat, thinning out high-altitude oxygen. Jet aircraft struggle to fly. Satellites in low orbit face increased drag and begin falling out of the sky. But the most shocking change is yet to come. Two suns mean two sources of solar wind, streams of charged particles that batter Earth's magnetic shield. If the magnetic field becomes overwhelmed, the upper atmosphere starts eroding, just like what scientists believe happened to Mars. Radiation levels rise, auroras become global. High-altitude electronics begin failing. Power grids flicker. This is the moment humanity realizes Earth is no longer the planet we evolved for. It is becoming something hotter, wilder, and far more unstable.
Long-term results. A new planet, a new biosphere, and the collapse of the old world.
As months turn into years, Earth begins its slow but unstoppable transformation into a two-sun world, a planet that no longer resembles the blue home humanity once knew. The first long-term consequence is a global temperature reset. With two suns, Earth's equilibrium temperature rises far beyond what our climate systems can regulate. Even the poles, once covered in permanent ice, melt completely. Sea levels rise by tens of meters, swallowing coastal nations and forcing billions to migrate inland. Former deserts grow even larger, merging into vast superdeserts stretching across continents. But ironically, not everything becomes dry. Some regions, especially near the equator, transform into boiling jungles with relentless humidity and daily megastorms. These zones become effectively unlivable for humans due to extreme heat stress. The human body simply cannot cool itself in such conditions. The biosphere undergoes mass extinction. More than half of Earth's species have disappeared within decades. Animals unable to adapt to constant light or intense UV radiation vanish first. Coral reefs bleach permanently. Forests near the equator collapse and are replaced by hardy, heat-resistant shrubs and grasslands. Yet life, as always, tries to persist. New ecological niches emerge. Fast-evolving microbes begin to thrive in the hotter oceans. Some insect species survive by burrowing underground. Plants develop thicker, reflective leaves. Earth becomes a laboratory of rapid evolutionary experimentation. human civilization changes just as dramatically. Cities move underground or underwater, protected from radiation. Agriculture shifts to vertical farms powered by artificial darkness cycles. Energy grids depend on advanced solar shielding technologies. Humanity becomes a nocturnal society, ironically, in a world where real night barely exists. Nations join forces to create the Global Solar Defense Network, an array of orbiting reflectors designed to reduce incoming sunlight by a few percent. Even that tiny reduction becomes crucial for survival. After several generations, humans adapt culturally and biologically. Earth becomes an alien planet, hotter, brighter, stormier, but still home. The question now isn't, can we survive the change? It's, can we survive long enough to evolve with it? Earth, once a predictable single-star world, becomes a place of chaos the moment a second sun enters the sky. The transformation begins instantly. The day-night cycle collapses, temperatures surge, and radiation levels spike. Life, from the smallest plant to the largest mammal, struggles to understand a world where darkness becomes rare and daylight becomes overwhelming. As hours turn into days and days into months, our atmosphere spirals into instability. Jet streams shatter. Hyperhurricanes form, oceans boil more vigorously, releasing greenhouse gases that accelerate warming. The magnetic field fights desperately against the doubled solar wind, but the strain slowly erodes our protective shield. What began as a dazzling cosmic sight quickly becomes a global emergency. Over the long term, Earth evolves into a new world entirely. Ice melts, seas rise, forests collapse, and familiar ecosystems vanish. Yet life adapts, transforms, and reclaims whatever space it can. Humanity survives by reinventing everything: cities, agriculture, technology, even social patterns. Underground habitats, artificial nights, and orbital sun shields become the foundations of civilization. And through all of this, one truth becomes clear. Earth was never meant to serve two masters. Our delicate balance depended on a single sun. But in this hypothetical future, we learn that survival is not about preserving the world we had, it's about adapting to the one we are forced to live in. A two-sun Earth is a world of extremes, chaos, and unending lights. Yet even there, humanity finds a way.